This video is for those of you who were not in our Zoom class the other day. Um, Again, attendance will be taken. You are expected starting on Monday to be in class twice a week for 45 minutes. Um, so when a substance changes phase, it's due to either heat being added or heat being lost. If we add heat to a liquid, we know it turns into a gas. Likewise, if a liquid loses its heat, it turns into a solid. And that's what happens when we put water in the freezer. The liquid loses its energy into the freezer, and the molecules slowly um, get slower and slower and slower until they become a solid. So the energy that goes into something, into a substance, can be used to do one of two things. It can be used to raise its temperature, or it can be used to separate the molecules and change from a solid to a liquid or a liquid to a gas. Because again, remember, in a solid, the molecules are really tight together. In a liquid, they're sort of moving around while still touching each other. And in a gas, they're far apart from each other. And so we look at it, something called a heating curve, which is a graph that shows how a substance changes um, in temperature over time, and it shows the different phase changes that happen as well. Um, the melting point of a substance is also going to be the freezing point. And if you think about that, if you think about, so for example, in Celsius, water freezes at 0 Celsius. So water gets colder and colder and colder. When it gets to 0, it freezes, it turns to ice. It goes from a liquid to a solid. Now imagine that you have really cold ice that's below 0 and you start to heat it up. When the ice is heated and gets to 0, as soon as it starts to get to 0 and now continue to move above it, it will melt. So once you get above 0, ice melts. Once you go below 0, water freezes. And so for a substance, it's going to be the same number, its melting point and its freezing point. The boiling point for water in Celsius is 100 Celsius. And so here's a heating curve. And so our axes that we have here are the y-axis, which is temperature in Celsius, and the x-axis, which is time, but it's also the heat absorbed, because we're adding heat to a substance continuously over this time. And it doesn't matter what our units in time are. We could say minutes if we want. And so maybe this is 20 minutes, we'll say. Okay. So we're going to start with some ice, a small ice cube if we want. And we had the ice cube chilled to minus 40 degrees Celsius. Very cold. And so this is initial time, and this is the initial temperature. So this is our starting point. We put the ice cube in a beaker and we put it on a hot plate. And we turn it on and we leave it at that temperature. So the heat is continuous. The heat energy is continuously going into this beaker that has an ice cube in it. And it's sitting on a hot plate. Okay. So we turn this on and we start. So the time has started. And as the first minute passes, we see that the temperature of the ice cube has started to increase already. Another minute passes, the ice cube is getting warmer and warmer. After maybe about 3 minutes, we've hit 0 degrees. The temperature is no longer going up now. You notice that over the 4th, 5th, 6th minute, even though this ice cube is still on a hot plate, its temperature is not increasing 1 single degree. Why? that heat energy is being used to separate the solid. So you have all these water molecules in a solid, all right next to each other, packed tight together. And so what we have to do is they have to be changed from a solid to a liquid. So we have to separate them from each other. And when you separate them, this energy that's going in from the hot plate into it is being used, instead of raising temperature, it's being used to separate these from each other. And that makes it into a liquid where it's now separated and it can sort of flow around. We know liquids can flow, whereas a solid can't flow. Okay? So we just sort of take it out of this really rigid structure that it's in, and it's now just, they're separated and it's now a liquid. And so at this point, our ice cube is now fully melted. And we know that because temperature starts to increase again. Remember, heat energy can only be used to do one of two things: raise the temperature of the substance or change the phase of the substance. So our ice cube's melted, still at 0, and over the next minute now, we start to see temperature increase, another minute temperature increase, and it continues for a few more minutes. Now we're at 100 degrees Celsius. And at this point, we obviously don't have an ice cube anymore. What we have in here is a bunch of liquid. And as we get to 100, it starts to change phase. It's starting to turn to water vapor, which we call steam. And so once again, even though it's that water still sitting on the hot plate, water can never go above 100 Celsius because water boils at that temperature and it changes phase. And so if we're past 100, it wouldn't be water anymore. Right? It would be steam. So over these next minutes, we can see this takes a long time to boil water. And that's because those attractions in here are pretty tight together still. They're still touching each other. A liquid, the molecules are still touching each other. And to make it into a gas, we have to have them far apart from each other. And so it takes a lot of energy to pull all these particles apart from each other and to break all those attractions that are holding them together. So remember, from our learning about polar substances, water is polar, and it wants to stay attracted to another water molecule. Because it's slightly negative, slightly positive. And remember we said we have these attractions? Well, that's what we're breaking right now. We're breaking those attractions. And so all of this heat energy that's going in is being used to separate these two water molecules from each other by breaking that attraction. And it has to do that millions and millions of times, billions of times, because even in an ice cube, you have billions, trillions of water molecules. At this point over here, now our water is fully gone. And all we have left is steam. Now, if this were a container that captured everything, we would be able to collect our steam. And so if this were a container with a lid on it up top, all that we would have left at this point after 20 minutes is gas. Is gas in there or water vapor in there. And so you would just see steam and you would see it starting to probably fog up in there a little bit. And what really is in there is just a bunch of gas molecules. Okay? And then again, we can heat that gas up because now that it's not water anymore, it's a gas, we can increase its temperature. So this is called a heating curve. And heating curves are really, really useful for us to understand when phase change happens, to understand where the boiling point is. Here, the boiling point's at 100, and our melting point is at 0. And so we know that matches up to water. And so we know this is a heating curve for water. Okay. So I hope that helps, and I hope it helps you with the work that you're going to be doing on heating curves.